I didn't label them A, B, C, D, but each of them has an inner layer and an outer layer, right? Kind of like I said, with chain rule, we had this. We saw this quite often, right? So let's look at the first guy. Which part would you say is the innermost part? A good place to start is inside the parentheses, right? If they give you parentheses, that's usually where the inner part's going to be. Right? That's usually where the inner part's going to be. Okay? Another hiding spot for the argument or the innermost part is up top. That guy. Exponent. They like to hide in the exponents as well. They like to hide in parentheses. They like to hide in exponents. And where is it hiding here? In the root, yeah. In the root. Even though you have parentheses, the root part is going to be what you use. Okay? The last one is a trig. Well, it's got parentheses, right? It's only got one part parentheses. So that's where. So all of those terms that I've highlighted, that's where we're going to start with U-substitution. So when we did chain rule, we started from the outside and worked our way in, right? When we connected them by chains, right? Like for example, I'll give you guys an example. Like when we had cosine of 4x squared, right? And we wanted to find derivatives. 4x squared was the inside, right? But we didn't start there. We started with the outside, right? We said, what's the derivative of cosine? Negative sine, right? We said negative sine and then rewrote the inside, right? And then eventually we got there, right? The derivative of that would be 8x. The 4x squared is 8x, right? Okay. We're going to do opposite now. So opposite now. So if I was to integrate, I would start with the inside and work my way out. Okay? So that's where it's the opposite. A lot of people like to think of the chain rule and U-substitution related. Well, they're related in that they're the opposite steps. Okay? So if that helps, it does, great. If it doesn't, don't worry about it. All right, so if you want to get confused even more, read the steps here. They don't make any sense to you right now because you haven't done a problem. But once you start doing a couple problems and you go back to these, you're like, oh, okay, that'll make sense. So right now, I don't even want to look at those yet because I want to do some problems, show you the mechanics, and then those steps will make sense. Okay? All right, so we're going to do these three. But first thing we want to do is find the argument. Okay? So for 2a, what's the argument? Yeah, 1 in parentheses, right? X squared minus 1. Okay. For b, what's the argument? The thing in the radical, x cubed plus 2. And then the last one, same thing as the first, right? I'm going to show you. So, should I say it now? Okay, so here's a little trick. Here's a little trick I used. Over the years, I've come to, no one taught me this, but I just kind of noticed it. This works about 95% of the time. There are that 5% where it doesn't work, and we have steps on how to do those, but about 95% of the time, this is how it works. The argument is, so if I were to find the derivative of the argument, would that function be in there as well? So in other words, if I were to find the derivative of x squared minus 1, what would the derivative be? What power would the derivative be? What degree would the derivative have? 1, right? Because it would be 2x, right? Boom, it's already in there. So I know this guy has to be the argument. Let's go to here. What's the derivative of the inside part? 3x squared. Is that also in there? It is, right? I'm not worried about the 3. I'm worried about the x squared, right? The x squared is there. It could be 10. It could be -6. I could care less what number is front. But I want the power to also be in there, right? C, it doesn't work. C, it doesn't work. There is a way to do it, but I'll show you later in the chapter. I'm not worried about it right now, but there is this one, right? If you were to find the derivative, you'd get 3x squared. Well, that's not x squared, that's x, right? So that's where the 5% where it doesn't work, but there are steps to do it that way, okay? All right, so now let's do the mechanics. So we said the argument was that guy there, right? Yeah. Once you do that, that's going to be your u. You're going to set that up as u. So you're going to go over here. That's why it's called U-substitution. The u part comes from the argument. So our u is going to be equal to x squared minus 1. Second step, find the derivative of u. In other words, du. What would du be equal to? 2x. So when you have this guy, when you do this, when you do a derivative, always have a dx with it. Always have a dx with it. Okay, I'll explain later why it has a dx, but anytime you're doing a derivative, this is step 3. Taking the derivative, you don't forget the dx. Okay, it's in there, but just don't forget about it. Okay? All right. Next step, solve for dx. How do I get dx by itself? Divide by 2x, right? Divide both sides by 2x. 1 over 2x. So now we have dx equals 1 over 2x times du, whatever it is. It's multiplication, but you don't have to put the times. All right? Now we're going to do the substitution part. Okay, stay with me. Okay, stay with me because if you're catching every other word, it's going to be confusing. But if you stay with me, it's not. It's totally not confusing at all. Okay? Okay, so now is the substitution part. We got the u part, right? That's where the u comes from. Where does the substitution part come from? Well, I'm going to go back to the original. I'm going to rewrite it. Instead of the highlighted part.
Why is the dx on the du side?
Because they swapped them.
Oh, he did swap them.
Yeah, because I solved for dx.
Oh, yeah.
I solved for dx, yeah. Okay. Yeah, I just did that, yeah. So instead of this, we've called it u. We've said this highlighted part is u. So I'm not going to write that part anymore. I'm going to say u. Everything else I rewrite. Okay, so before I go on to the next step, does everyone see what I just did? Yeah. All I did was said, hey, that thing I called u over there, I'm going to call it u. Cubed times 2x dx. Sorry, I should put the dx. Oh, sorry. And then the dx I'm also going to substitute for. What is dx equal to?
1 over 2x times du.
So I'm going to substitute that as well. So instead of dx, I'm going to put 1 over 2x du. That is the substitution part. That's the substitution part. Okay. Next step, simplify. I have u's and x's, right? I should only have u's after this part. So if you do it correct, you're only going to have u's left. Your x's should cancel out. Will the x's cancel out? Yes, they will, right? X divided by x makes 1. Yeah. And not only that, right? 2 divided by 2 makes 1. Yeah. Okay, so let me rewrite what I got. So I have u cubed times 1 du. The 1 you can move in front, or you don't even need to write. It's not going to affect anything at all. So you can take that 1 and move it to the front. Or you don't have to write it at all. So it's not going to affect the problem. Now what do I do? Use the power rule. What did the power rule say to do? Now I'm actually going to do the antiderivative. What did the power rule say?
Add 1 divide by the new power.
So I'm going to take u, add a power. So what power is u going to be 2 now?
4.
Divide by the new power. So I could divide by 4, but instead of dividing, I'm just going to put 1/4 in front because dividing by 4 is the same thing as multiplying. The 1 is meaningless, doesn't change anything. Since there were no bounds, I need a plus c. Last step, move everything back in. I substituted out the u, now I'm going to substitute in the u. So what was u equal to?
X squared minus 1.
You are done.
What happens to the du?
What's the derivative of? So what I did was I found the antiderivative. What's the antiderivative of the derivative? Itself, right? It cancels out, right? If you find the antiderivative of a derivative, it just cancels out,
Okay.
right? Every problem we've seen so far, right? Even on your quiz, like you had on your quiz, you had this one right here. You had, I forgot what it was. It was like 2 to 4, 2x plus 1 dx, right? Think of something like that. Did that dx affect your problem? No. So why would a du affect the problem? It wouldn't, right? Same, that's another way to think about it. That's another way to think about it, okay? All right, let's try the next one. Let's try the next one. So always, now on all of these problems in your notes, they're all going to be U-substitution problems. But when you see them on a test or a quiz, are they all going to be U-substitution problems? No. Some of them will be just power rule problems. You don't need U-substitution, right? So you always, before you start the process, you should always say to yourself, do I need something other than the power rule? This one I do, because I have 2 functions times each other. I can't use the power rule, okay? Power rule won't work for this guy, okay? Whereas this one you saw here, yeah, I could use the power rule. I could do the power rule in there, okay? So there's no need to do not chain rule, there's no need to do U-substitution unless you need to do U-substitution. Okay, so first step. Even before we start any of our steps today, what do we always do that we did last semester that we will continue to do this semester? What do you think? Rewrite it, good. Rewrite it. I don't like roots, I like powers. So I'm going to write it with a power. Okay, that's the problem I like. We identified u. We identified the innermost part. What did we say the innermost part was?
X cubed plus 2.
Okay, so that's going to be our u. Next, find du. What is du?
3x squared.
3x squared dx. Always put the dx there. Next step, solve for dx. So what am I going to do to get dx by itself? Divide by 3x squared, right? So 1 over 3x squared. I'm going to flip-flop these. So dx is going to be there. And then I have 1 over 3x squared du. And I'm going to pause there for a second. I don't want to go too fast. It's the same mechanics every time, so you'll get faster at it, and I don't mind if you go fast or you go slower, but I'm going to pause I'm not going to go as fast just because I want to get you guys used to it. Okay? Next step, substitute. I'm going to rewrite it, except whatever u was, I'm going to put u. So the highlighted part was u. And dx is 1 over 3x squared du. Now you might have x's and u's mixed together. I don't want that. I just want u's. So if I did this correctly, the x's should cancel each other out. They do. X squared divided by x squared makes a 1. This won't happen all the time, but 3 divided by 3 also makes a 1. So I have 1 times u to the 1/2 times 1 over 1, or just du. Okay, now all I have is u's. Now I can proceed to the next step, antiderivative. Antiderivative says, use the power rule. Add a power, divide by the new power. So instead of dividing by 3 over 2, I'm going to multiply by the reciprocal. Plus c. Last step, move u back in. U originally was x cubed plus 2. You're done. That is the antiderivative. This guy is the antiderivative of that. How do you check your answer? Let's say you have an extra 10 minutes on your test and you want to make sure that's the right answer. How would you check this so that it's correct? Find the derivative, yeah. You guys already have a built-in way. You guys have been doing it all last semester, right? If I were to find the derivative of this, I better get that. If I didn't, then I must have done something wrong. Okay, let's go to the next one. So there's no C there because I told you that one is kind of a different case that we'll talk about later in the chapter. There's a way to do it, but I'm not going to worry about it right now. Okay? All right, so here we go. Can I use the plain old power rule for this guy? Yes, I could. It'd be a lot of work, but I could. How would I do it? Well, it's to the 4th power, right? So I would need to go 3x minus 2 times 3x minus 2 times 3x minus 2 times 3x minus 2. And then I'd have to do FOIL, and then FOIL, and then FOIL, and you could do it. You would need to do it quite a bit. Could you do it? Yes. Even if that power was like the 20th power, you could still do it. I would highly suggest not doing that. There's better ways to do it. It's called U-Substitution. Okay? Just like if this was a derivative problem, could you do this using the power rule? Yeah. But why not? Why use the power rule when you can use the chain rule? Okay? So, if you're going to use U-Substitution, start with the innermost part. What's the innermost part? Okay, that's going to be your U. So identify the U. Next step, du. What's the derivative of u?
3.
Just regular old 3 with a dx, right? Next step, solve for dx. Divide by 3. So dx equals 1/3 times du. Substitute. Instead of the blue, I'm going to write what it substitute is. U. That's what the substitute version of that is. And instead of dx, I'm going to write 1/3 times du. So before I go on to the next step, are there any other letters besides U? The D don't count. Is there any other X's or Y's or A's or, no, right? So we could skip that step. The 1/3 though, I would highly suggest that you move the 1/3 to the front and just multiply the antiderivative with it. Don't deal with it inside, it's just a 1/3 times. So we're gonna, so all we're gonna do is multiply a 1/3 times our answer. Now I can use the power rule. Add a power. I need the 1/3 in front, so don't forget about that 1/3. Add a power, divide by the new power. Instead of dividing by 5, I'm just going to put 1/5 plus c. 1/5 times 1/3 is 1/15. Move u back in, and you are done. Sometimes you'll have it like this. Sometimes you'll look at an answer key and it'll be like this. Are those two the same thing?
Yep.
Yes. Divided by 15 and taking 1 out of 15 is the same thing. Okay. All right. So the hardest part about using U-substitution is not the U-substitution part. It's the simplifying. It's always the simplifying. When you get powers mixed together, sometimes it's hard to do that. I'm telling you right now. The biggest mistakes I always see aren't, people know how to find u. They know how to find derivative of u. They know how to move it back in. But after that, with the powers, sometimes that's where the mistakes happen. Okay? All right, so we got, let's see. Oh, perfect. We got about 15 minutes. Okay. Rewrite. Okay. I can't use the regular power rule because how do I distribute that to both to the binomial? Don't know. So dx. Solve for dx. 1/5 du equals dx. Ready to roll. Substitute. U to the 1/2. Dx is 1/5 du. All I have is u's. I'm going to move the 1/5 to the front, not let it affect the problem when I do antiderivative. So I have 1/5 u 1/2 times du. So we get 1/5. U is going to be to the 3/2 power. Divide by 3/2. That's the same thing as multiplying by 2/3 plus c. What do we get? 2/15. Put u back in. 3/2 plus c. Okay.
Oh no.
All right. So now we're gonna put some trig. It's not going to change anything we did. You guys did derivative of that last semester. It's similar. So it's sine of 3x. That's what the angle is. So just like we used chain rule last semester, we're going to have to use to find the integral to work our way up, right? When we're finding derivatives, we work our way down, f prime, f double prime, f triple prime. Opposite is antiderivatives integration. Okay, so that's what we're doing. Okay, so the first thing is innermost part. What's the innermost part? 3x. Okay, so that's going to be our u. Once you get that part, the rest of it kind of rolls. So u is 3x. So what is our du going to be? Just 3, right? 3 dx. Solve for dx. Divide by 3. So we get 1/3 du equals dx. Substitute. Sine is going to stay. I didn't do anything with sine. Sine is going to stay. The angle is going to change. That's going to become u now because that's my u that I chose. And then dx is going to become 1/3 du. Okay. There's no other letters besides u. 1/3 to the front. So we got 1/3 times sine of something du. All right. Now let's do antiderivative. 1/3 times, what's the antiderivative of sine? Negative cosine, good. Negative cosine. Negative cosine of u plus c. So -1 times 1/3 is -1/3. Brings u back in, and you're done. It's not that much different.
Oh. You.
Okay. Let's see. Okay, we got about 10 minutes. Let's see, what do we got next? Let's do, so the rest is just different types of functions. That's it. There's no extra stuff that you haven't seen. Okay? So this guy we can actually use. Again, we can't use the quotient rule. I know a lot of you, some of you are looking at it, you're like, oh, quotient rule. That's for derivatives. We're not doing derivatives. We're going antiderivatives. So we have two options. I have the power rule, plain old power rule, or U-substitution. Okay? So the first thing I'm going to do is anytime I'm doing antiderivatives and I have a fraction, I'm going to try to undo that fraction. So what was it that caused ln to be on top and x to be on bottom?
X is a negative exponent. X is.
Or I'll show you, yeah, you could do that too, but I'll show you, I'll just, not even that far, I'll just do this. It would be x to the -1, right? It would be x, you could do that, that's not wrong. But the reason I'm doing it this way, remember what I told you about 15 minutes ago about how do I choose u? So I have two options. You have the natural log or you have 1/x. Which one are you going to choose? Well, after I find u, what's the next step? du. We want du to be in there. So which one's derivative is also in here? The natural log, right? The natural log's derivative is 1/x, right? That's how you can make that decision. Now, let's say you choose wrong. Let's say you choose 1/x as u, and then you try to do it that way, derivative and so on, and then you plug it back in, it won't work. So then you just know it's a longer way of getting there, but you'll know, hey, I did it wrong. That's the nice thing about U-substitution is, if you choose the wrong u, you just go back and choose a different u. Did you, that 5 minutes you spent? Oh well, but at least you know what u is now. Okay? So, since I know, I'm going to choose the natural log of x. Since du is going to be what? What is the derivative of a natural log? 1/x dx. Solve for dx. So instead of dividing both sides by 1/x, I'm going to multiply by the reciprocal. That part is a place where students often, especially when it deals with fractions, again, solving for dx is not calculus. It's pre-algebra, really. But sometimes they get confused with that. Okay, so that's a common mistake there, especially when you're dealing with fractions. Okay? All right, let's move it back in. Let's move everything back in. Instead of natural log of x, I'm going to put u. 1 over x, I didn't change. I didn't do anything with that, so that's still there. dx is no longer there. We know what dx is because we solved for it, right? It's x times du. If I did it correct, how do I know I picked the right u? Because the x's should go away. Will the x's go away once I simplify? Yes, they will. So that means you did the right u. If you get to this point and the x's don't cancel out, you picked the wrong u. So now I have u du. What's the antiderivative of u? It's the first power, right? Wouldn't it be u squared divided by 2? Add a power, divide by the new power? So 1/2 u squared plus c. Put u back in. Done. So we're not going to actually do the next one, but what I want you to do is do the pre-work, rewrite it. It's not good right now. I want you to rewrite before, so do the before part. How would I rewrite that guy? And then tomorrow we'll start with that. How would I rewrite E